so this is the workbook, the first page in the workbook. Do you guys have any questions about this page? Okay, yes ma'am.
Number 5.
Number 5. All right. So let's take a look at number 5. All right. So on this one, now this is 9 times everything less than that. And this is 6 times everything less than that. So this is all multiplication. Doesn't all multiplication have to be done first?
Yes.
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 So if we were using our calculators, this is fine. Just make sure we group it. If we're not using our calculators, how would we do this problem? Well, both of these have a 6 factorial in common, don't they? Because 9 is 9 times 8 times 7 times 6 times all the way down to 1. So if I took out a 6 factorial, wouldn't that leave me with 9 times 8? 8 times 7 minus 1 times 6 factorial. We could do it that way. But you can't just say 9 factorial minus 6 factorial is 3 factorial. Do you see how they're not the same? Okay? So this is a great problem to have our calculators for. Just make sure you group the numerator. Because otherwise, if you enter it, if you just enter in your calculator 9 factorial minus 6 factorial, divide by, and then group this, your calculator is going to do exactly what you told it to. It's going to follow order of operations, and it's going to do 6 factorial divided by 3 factorial first, and then it'll subtract that from 9 factorial. So what you have to do, because this is a numerator, is go ahead and group that when you enter it on your calculator.
How do you get to factorial again on the calculator?
You hit the math button, you arrow over to probability,
Okay.
and then you should see it.
Thank you.
Okay.
What was the right answer?
The right answer was 60,360. Yes, sir.
So it's a word problem on 434, 5 and 6. Wouldn't that be a combination?
Anything else on this first page? And then I'll go to the second page, okay? Yes, ma'am.
Number 11, B and C.
Number 11, B and C. Okay, we have 11 boys and 14 girls in the kindergarten class. And how many ways can she select 5 boys out to pass books? Okay, so what are you thinking we need to do here? How many are we choosing? 5. Okay, is this a combination or a permutation?
Combination.
Combination. And how many boys does she have to choose from? 11.
No.
Does that make sense? Okay.
I just didn't get it.
And then on this one, and how many ways can she select 3 students to carry papers to the office? So we're not assigning roles again. So this time it's still a combination. We are going to choose 3, but since they're students, we're out of the entire pool this time, so it would be out of 25.
Oh,
Yes,
would
sir.
that be acceptable for like showing your work? Just doing that?
I'm about to give you one, and we'll see if you can do it both ways. Okay? Actually, do that problem without a calculator.
Oh.
Find the answer without everybody in here. Find the answer to number 11 part B without using a calculator at all.
So should just release me.
You ought to know what it is. You ought to be able to check it because you've already got an answer. Combinations, yes. Can you show me all the work and do it on the no calculator part of the quiz? That is what we're trying to see.
Probably not.
Okay, what is the definition? What is the formula for combination? Because that's what you have to know to be able to do it without a calculator in
I
it.
know it's 11.
Hey, were you using your calculator to like
You got it.
multiply the numbers? So like 10.
Okay, so it's n factorial over r factorial times n minus r factorial, right? All right, so how would we do this without a calculator? Hopefully you all got to this point. Because if you didn't get to this point, that means you didn't learn yesterday's lesson. That means maybe I didn't show enough work on my problems to where I knew a combination works this way. Okay, so we do 11 times 10 times 9 times 8 times 7 times 6 factorial over 5 times 4 times 3 times 2 times 1 times 6 factorial. And then just start canceling. So this goes into this, 3, and this goes into this, 2, and this cancels with that. So we're doing 6 times 7 is 42, and 42 times 11. All right, all my students from last year, what's the shortcut? Multiply times 11?
Yes.
I didn't say yes, I said what is the shortcut?
Multiply times.
Split the numbers, and what do we put in the middle?
1.
The sum.
Yeah.
462. Okay, the person that's laughing, make fun of the person that knew more than them.
Yep.
Oh no, I'm just very insecure and I don't like to split.
Okay, so whenever you multiply by 11, a two-digit number, you split the numbers, put the sum in the middle. 462.
Why is it on?
Yeah, that's
the
it.
bottom?
Can you do another example of that?
Oh, yeah.
What, multiplying by 11 or just
Yeah,
canceling?
11.
Like if we did 35 times 11, you split the two numbers and you put their sum in the middle. 75 times 11, you split the two numbers and put their sum in the middle. Oops, it's more than 10, it's more than 9, so we put 2 here and carry our 1. You don't have to know how to do that. You could just multiply times 11. Yes, ma'am.
For when you're canceling,
Yes.
why would the 5 and the 10?
The 5 and the 2 canceled with the 10. Took 2 of them.
Oh, okay.
Yes, ma'am.
Can you do number 6?
Number 6. How many ways can a debate team choose a president and a secretary? We're assigning offices. This is no longer a group or a committee. We are assigning roles, so this is not a combination, it is a permutation. So it's the permutations of 10 and how many do we have? Just president and secretary, so we are choosing 2. So it would be 10 factorial over 10 minus 2 factorial. So it ends up being 10 times 9 because the 8 factorials cancel, so it is 90. That one we should also be able to do without a calculator. So these could be on the no calculator page, but if they're on the no calculator page, you best know how to use the formulas. Okay? Gentlemen, we good with that?
Yes, ma'am.
Awesome.
Yeah, yes,
Okay, let's go on to this page. Questions about page 435. Whatever the next page will be. Okay, yes ma'am?
I missed 5 and 6 at the bottom.
Okay, 5 and 6. Anything else? Yes ma'am.
3A.
3A, okay. So let's do 3, 5, and 6. Okay, Rosalie needs 2 cable locks, but there are 13 types of locks to choose from. How many ways can she choose 2 different locks? We're just picking locks. We're not picking combinations.
Let's see what order.
So if we're just choosing 2, we're not assigning them any roles. Would this be a permutation or a combination? Combination. So it would be the combinations of 13 choose 2. So if we were showing our work, it'd be 13 factorial over 2 factorial times 11 factorial. So it ends up being 13 times 12. The 11 factorials cancel over 2. And this goes in there 6. And that gives us 108.
Where's all of them?
No,
just kidding.
78. Not 108.
Dang, Miss Willis.
That was way off.
I did 12.
I did 18 times 6
That's alright.
in my
You're
head.
still the smartest math teacher.
Did you get used to it?
Alright, are we good? Okay, and we talked about why we call that a combination.
That's, yeah. It's the same way you did those, but it's 6 digits. You put a 6 instead of
Okay, and let's take a look at 5 and 6. Rosalie wants to lock her bicycle near the library. There are 7 slots still open on the bike rack. Choose the letter for the best answer. Rosalie arrives at the same time as 2 other cyclists. How many ways can they arrange their bikes in the open slots? Okay, so the arrangement matters here, doesn't it? Because we're talking about arrangement. When we talk about arrangement, that's telling us it's going to be what? A permutation or a combination? Permutation. So this would be the permutation of 7, and how many bicycles are we arranging? 3. So it would be 7 factorial over 7 minus 3 factorial. So it would be 7 times 6 times 5. And that would give us C, 210. Okay, suppose Rosalie arrived just ahead of 2 other cyclists and selected a slot. In how many ways can the others arrange their bikes in the open slots? Okay, so this would be the permutations of what? 6, choose
2.
2. And so this would give us J.
I knew that as a goal.
When you see arrange, that's going to be a hint for permutation. Okay?
Oh, yeah.
All right, and then next we did the bookwork. Questions about the bookwork? Yes, ma'am. 13, 14, and 15. All right. Good. What else? Okay, so we got 13, 14, and 15. Let me take a look at these. Oops. All right, number 13, there are 5 airplanes ready to depart. Runway A and runway D are available. How many ways can 2 planes be assigned on runways without using the same runway? Okay, so if we take a look at this, we've got runway A, where we can have 5 different choices. I'm up in the, what do you call that? The person that tells the planes where to go.
The director, air traffic.
I'm the air traffic controller, and I've got 5 planes, and I tell one of the 5 to go to runway A. So I had 5 to choose from for runway A. Well, now I've chosen one. How many are left for runway B? 4. So we could think of this as a counting principle, or you could think of it as a permutation, which is what it's worked out as here. The permutations of 5 choose 2. 5 factorial over 5 minus 2 factorial is 20. So there are 20 ways to assign those 2 planes, to those 2 runways. Okay. Let's take a look at the question for number 14. Whoops, it's not there. It's here. So number 14, how many choices of 3 hamburger toppings are possible? So here's our hamburger, and how many do we have to choose from? 6. Now, unless you've got a really picky child, they don't really care if you put the mayonnaise on first or the ketchup on first.
No.
Now, if you have a really picky child, they would starve at my house because
I'm picky.
it does not matter the order in which you put the condiments on your hamburger, or it should not.
I don't eat anything on my hamburger.
It should not. So this should be combinations of 6, choose 3, because we're choosing 3 toppings for our burger. And if you don't like the order, when I put it in front of you, rearrange.
I don't think I did the right 15. No, I did the right 15. Wait, what number are we on right now?
14.
We're talking about number
Okay,
14.
Kyle, you're...
Number 15 is up here, and number 15 is a little more complex.
Oh, I got it right, though.
Great.
I got the right number for number 14.
Mr. G-Bird.
We're so happy.
So,
I didn't get this at all yesterday.
But,
What, electric class?
but it's all making sense?
Yeah, because I went home and studied. And
Okay.
I did my homework.
Yeah.
Those are exciting things to hear. Okay, are we ready to talk about 15?
Yeah.
Okay. So number 15, in the United Kingdom's National Lottery, you must correctly select a group of 6 numbers from 49. So suppose that the contest were changed to selecting 7 numbers. How many more ways would there be to select the numbers? Okay, now, you guys may never have played the lottery, but does the order that I bubble the numbers in on the sheet matter?
Yes.
No, because when I turn it in, whether I pick 14 first or whether I pick 2 first, will they know? No, because they always just put them in order, numeric order, no matter which order I selected them first in. Okay? So, we're going to do the combinations of, we have 49 numbers to choose from, but we only get to choose 7. This gives us the total number of possibilities, the number in our sample space, when we're choosing 7 numbers. And it wanted to know how many more would that be than if we had chosen 6. So that would be the combinations of 49 choose 6. And so we're just doing the difference in these two, and they showed you the entire bit of work, but probably most of you just punched this part into your calculator. So if we up it from 6 numbers to 7 numbers, how many more possible combinations are there? 71 million.
You got that wrong, Chris.
916,768 more ways. If we just add one more number choice.
I got it right now.
Yes, sir.
Number 37.
Oh, because it,
37.
it mattered.
B.
Okay, let's take a look at 37.
I chose the correct one. Never mind.
Okay.
This will be.
We're good.
Why was that one a combination, not a?
Because she explained that at the beginning. It doesn't matter which one you bubble in first, because if you get the numbers right either way, you're still going to win.
Oh, is that the lottery one? Okay.
Yeah, that's the lottery one.
Right?
Yes, you are right. Okay, I want to take a look at what the question was for 31 real quick. You have extended. All I hit was next. How is next a hard number?
Chris, stop.
Try 608.
Bad reference.
I'll try it.
Kyle, what did you do yourself?
They're all null now.
Have them take 1 to see.
Okay, okay, in this one, it said, why are there more unique permutations? What did you guys guess about geese? Did you get it right? Because the E is repeated. So what would we have to do to actually find the number of unique permutations? Just like with combinations where we have to divide out that duplication, in this case, we would have to divide out the
Permutation.
duplication.
Wait, I don't.
We would have to divide out the duplication. So, let me give you an example. Okay, here is a fabulous last name.
So that.
All right, Willoughby. Okay, how many letters is it?
Ow! 10.
10.
10.
Okay, so if I ask you how many different ways I could arrange this, you might go, well, I have 10 choices for the first letter, and then 9 choices, and then all the way down to 1.
There's 2 different words in your name.
Well, wouldn't it be
But-
26 then 25?
But what does this double L right here do to it?
It means that it doesn't matter what order those two are in.
It doesn't matter. We couldn't distinguish between those 2 letters. So what that does is that limits our number of unique permutations. And when we have a repeating here, we have to divide that out. Does it make sense that you would have to do that?
Oh, okay, I get it now. Yeah.
Okay. All right. Today you have a worksheet for homework. If you're not here, I will post it to my website, and you can pull it up from there so you can have it tomorrow. And that's going to be the end of our recording today because you guys have the rest of the class to work on your classwork/homework.